1735, Carl Linnaeus' Systema Naturae. The year 1735 marks a pivotal moment in the history of biological understanding. The publication of Carl Linnaeus' Systema Naturae. At the dawn of this groundbreaking work, the natural world observed was a chaotic, unorganized spectacle. The absence of any universally accepted system for classifying living beings characterized previous efforts. Before Linnaeus, the practice of describing organisms was largely descriptive, varied, and unsystematic, a situation severely impeding scientific communication and comparative study. The lack of a unified nomenclature meant that an organism could be known by multiple, often regionally specific names. Consequently, scholars found themselves struggling with inconsistencies and ambiguities. The scientific revolution, with its emphasis on empiricism and observation, created a climate where the study of nature flourished, yet such growth exacerbated the need for order. The ever-growing volume of new discoveries and observations highlighted the inadequacy of current classification methodologies. The prevailing methods, often based on superficial similarities or arbitrary criteria, produced systems rife with inconsistencies. Before Linnaeus, attempts at classification included various approaches. Some focused on utility, categorizing plants based on their medicinal properties or economic use. Others attempted to group organisms by their physical characteristics, yet these methods were often inconsistent, leading to overlapping categories and limited predictive value. These early endeavors, though crucial in their pioneering efforts, lacked the systematic rigor and universal applicability that became hallmarks of the Linnaean system. John Ray provided a significant philosophical precursor. Ray's work signaled an important shift towards a more natural classification system, aiming to reflect the inherent relationships among organisms, rather than solely their utility. Ray's emphasis on detailed observation and the attempt to establish a consistent vocabulary for describing plants paved the way for Linnaeus. Linnaeus built upon Ray's foundation. He adopted a keen focus on the relationships between organisms, establishing a hierarchical system. The Systema Naturae introduced a groundbreaking innovation, a hierarchical classification system utilizing binomial nomenclature. This simple yet profound concept laid the foundation for modern taxonomy. Linnaeus envisioned a system that would be universally applicable. His ambition was to create a universally accepted framework for organizing all known organisms. The structure, organizing life forms into nested categories, presented a unique breakthrough. The structure started with broad groupings like kingdoms, then the structure subdivided into classes, orders, genera, and finally species. Each level was defined by shared characteristics, arranging organisms in a logical hierarchy. This system was designed to reflect a presumed natural order, enabling scientists to arrange and compare organisms with unprecedented clarity. At the heart of the Linnaean system lay binomial nomenclature. Each organism was assigned a two-part name, a genus followed by a species. This system provided each organism with a uniquely identifiable name. It resolved the ambiguity of previous systems. Prior to Linnaeus, organisms possessed lengthy, descriptive names, often varying between different authors. The use of binomial nomenclature was simple, efficient, and readily adaptable. The naming process allowed for clear, concise, and consistent communication. This seemingly simple change revolutionized the scientific process. It allowed researchers from diverse locations to unambiguously refer to specific organisms. The immediate impact of the Systema Naturae was nothing short of transformative. The systematic approach and the consistent use of binomial nomenclature offered a language for biology. Its universal appeal was immediate. Scientists across Europe and beyond adopted the system. It provided a foundation for comparative studies, opening the door to deeper understandings of the relationships. The potential of universal application was immediately recognized. The system began to replace the fragmented and inconsistent methods of the pre-Linnaean era. The Systema Naturae, in its earliest editions, consisted of a concise work, offering a framework for classification. The initial reception was, unsurprisingly, mixed. Some scientists embraced the clarity and efficiency of the system. Others found the reliance on specific morphological criteria controversial. There were critics of Linnaeus' classification of plants based on their sexual characteristics, which was a novel approach at that time. The primary focus on reproductive structures for classification was unfamiliar, and some found it somewhat provocative. Yet, the underlying value of a universal, organized system of classification ultimately prevailed. The initial publication, though compact, laid the groundwork for an evolving system. The Systema Naturae provided a framework that would be refined, expanded, and adapted over subsequent editions, eventually influencing generations of scientists. The year 1735 marked a pivotal moment in the history of biology, With the publication of Carl Linnaeus' Systema Naturae, this work, more than just a catalogue of organisms, presented a revolutionary system for the classification of the natural world. Its lasting influence reverberates even today. Linnaeus systematized the chaos of biological diversity into a hierarchical structure that allowed for a more coherent, ordered understanding of life. The Systema Naturae established a precise framework. It arranged organisms into a descending hierarchy: kingdom, class, order, genus, and species. This structure, though not entirely original to Linnaeus, provided a standardized nomenclature, rendering the scientific dialogue concerning biological entities far more efficient. Each level in this hierarchy represented a degree of relatedness, moving from broad groupings at the kingdom level to more specific distinctions at the species level. This system, a cornerstone of modern taxonomy, offered a means of organizing and understanding the vast array of living beings. At the heart of Linnaeus' system was the emphasis on morphological characteristics. He used observable traits, especially those of reproductive structures, to distinguish between different species. The sexual system of plants, a particularly innovative aspect, classified plants primarily based on the number, arrangement, and structure of their stamens and pistils. This approach, though criticized initially, proved exceedingly useful. The criteria for defining classes and orders, such as the number of stamens or the presence of fused petals, enabled a clear and relatively straightforward means of identification. The use of these particular morphological attributes provided a practical base for classification, even if it lacked awareness of evolutionary mechanisms. Binomial nomenclature constitutes one of the definitive achievements of Systema Naturae. Each organism received a unique duport name, comprising the genus and species. For example, Homo sapiens, the genus Homo representing humans, and sapiens indicating the species, provided a standardized, universal language for biological communication. Before Linnaeus, organisms were often described using lengthy, descriptive phrases, a system that was cumbersome and prone to ambiguity. The binomial system provided a succinct and unambiguous label, essential for international scientific collaboration. This simple, yet profound, innovation streamlined the process of identification and communication between scientists across the globe. The introduction of the sexual system and binomial nomenclature sparked both acceptance and criticism. Some contemporaries, notably the botanist Joseph Pitton de Tournefort, questioned the basis for classification founded on sexual characteristics. Though Linnaeus' system was initially deemed somewhat provocative, its advantages soon outweighed the concerns. The utility of a universally applied system of naming and classification steadily won over the scientific community. Linnaeus addressed the criticism systematically in subsequent editions. He refined and expanded his system, incorporating new discoveries and responding to feedback from his peers. This willingness to adapt and refine his work helped ensure its enduring relevance. The Systema Naturae included specific examples, such as those of plants classified based on the arrangement of their stamens and pistils. He detailed each plant's characteristics, specifying genera and species. The initial editions of the Systema Naturae included both familiar and exotic plants, offering explicit demonstrations for using the categories to classify different forms of life. This hands-on approach to demonstrating his classification system proved invaluable in its early acceptance. The classifications of animals, too, were given similar clarity. These explicit examples made Linnaeus' system more accessible to other scientists and helped disseminate the concepts. Systema Naturae also harbored philosophical implications. Linnaeus aimed to create a natural system. He hoped to reflect the plan of creation, to arrange organisms as they were intended by the divine creator. Linnaeus' intent was to depict the order within nature, mirroring the divine order. He believed that discovering this order would reveal the creator's intentions. This perspective, prevalent in the 18th century, motivated his work and influenced its reception. While the concept of a natural system proved to be difficult to realize fully, this ambition drove Linnaeus to seek deeper relationships between organisms. The limitations of Systema Naturae resulted primarily from the lack of evolutionary understanding. Linnaeus focused primarily on observable traits. He held no concept of the evolutionary relationships between the species. He adhered to a static view of creation. His system, however, was a product of its time. It prepared the ground for its modern refinement. It proved a practical framework. The lasting legacy of Systema Naturae is difficult to overstate. It laid the foundation for modern taxonomy. It continues to be utilized, forming the basis of the system of classification still in use today. Its impact on the natural sciences extended beyond biology. The principles of classification and the standardized nomenclature provided a model for other scientific disciplines. Linnaeus influenced subsequent naturalists, including Charles Darwin, who built upon his work, the binomial nomenclature became a universal language for describing the natural world. This standardization facilitated communication by allowing biologists worldwide to discuss organisms confidently, which advanced cooperation, experimentation, and research. The profound impact of Systema Naturae is evident in evolutionary biology and biodiversity research. This work also demonstrates the lasting importance of a universal classification system. Its influence continues to shape our understanding of life on Earth.